Hello dear students, this is Dr. Sourav sir's class. We are now solving mathematics optional paper 2 from 2024, and this question appeared in our paper. So the question says us to locate the poles and their order for the function fz, which is equals to 1 by z sine pi z and z plus half. Okay, and also find the residue of fz at these poles. So what is our pole? Pole is our denominators 0 or denominators, yeah, 0. Then what will be poles here? So at z equals to 0, the term z in the denominator causes a pole at 0. Okay, so near our z equals to 0, we get f of z, which is asymptotic to 1 by z, and so that is now simple. That means it's of order 1. Now again the same case will appear for our z equals to minus half, then our z plus half is 0. So that will be now fz will be asymptotic to z plus 2, z plus half, and blah blah blah. And so it's also our is, yeah, okay, and is our simple pole, which is of order 1. Okay, now what can be done? Now for our sine pi z, we have to think that at z equals to n, where my n is equals, my n is belonging to z, then also the same thing appears. So that in the term sin pi z in the denominator vanishes at z equals to n, where n belongs to z. So near z equals to n, what happens? Our sin pi z will goes to pi of z minus n. Yes, that is approximate to pi into z minus n, so that the pole z equals to n for n does not equals to 0 is simple. That means it's also of order 1. Okay, the first part of the question is done. That means the locus to locate the poles and their orders. So the poles are our 0, half, and 0, minus half, and n, and they are all simple poles. That means they are of order 1. So now we have to find the residue of fz at these poles. Okay, let me change my font color now. Okay, yeah, residue at z equals to 0, we are finding this. Now we have to know the formula for to calculate residue. That formula is the residue of fz at a simple pole z equals to 0. The formula is residue of fz naught, which is equals to our limit z tends to z naught, and it's z minus z naught fz. As our poles are simple, so this is of power 1. If their poles are not simple or anything, then the power will be n, and n equals to the order of the pole. This is the formula of residue. Okay, now at z residue at z equals to 0, what will happen? So our race, yeah, will be equals to our limit z tends to 0, z minus 0, 1 by z, that is my the same function fz sine pi z, and it is our z plus half. Okay, then this will go away. So this will be my 1, and this is our z plus is this. Okay. Then what will happen? Then it will my answer be 1 by, that's, as our sine pi z goes to pi z, then it will be my pi into half. So it is 2 by pi. Now, again we have to find the residue, which is our f minus half. Then what will happen? Then this term will, then z plus half will cancel out in this process. Yeah, this will cancel out. And what will I get? Hmm, it will be 1 by minus half of sine minus pi by 2. So that will be what? That will be minus sine pi by 2. So minus and minus, that will be plus half, and it's my sine pi by 2 up below 1, and then it is 1 by half, so it is 2. So our residue at f minus half is now 2, and we have to find the residue at z equals to n. So our residue at z equals to n, where our n is not equals to 0 comma minus half, and n belongs to z, what will happen? So now for n belongs to z, the poles come from sine pi z equals to 0. So our z is equals to n. Then the residue res f n is equals to limit z tends to n. Yeah. And the denominator is my this. Now what will happen? As we saw that, let me change my color to write a fact that at z equals to n, we saw that our sine pi z is equals to pi of z minus n. Then we have to put it in our this limit. So what will we get? Yeah. So we get limit z tends to n. This is my z minus n will remain same, and this is z into pi minus z by pi into z minus n. So it will be my z plus half. So what will we get? So our this is 1 by n pi n plus half. Yeah, as this and this will cut out, and this will be n, and this will also be n. Yeah, then this is 1 by n pi into n plus So I am writing the final answers in our question. So our poles are 0, minus half, and n, where n is not equals to 0 and n is an integer. So our residues at those poles are residue at 0. That means res f0 is my 2 by pi, and my residue at minus half, so res of f minus half is my 2, and residue at z equals to n, where n is not equals to 0 minus half and z is an integer. Then our residue at n, res f n is equals to 1 by n pi into n plus half. Okay, these are the required solutions of this question. Okay, thank you guys. Hope you understood. Thank you.